This video is going to show you kind of how to annotate this article that you should have pulled up in Amplify. If you don't have it pulled up in Amplify because your Amplify is not working, you can play this video the whole way through and it will read it to you. So the first thing I see is the title. It says Listening to Earth. I'm going to stop right there and think about what does that actually make me think. You can highlight something like that with your mouse and then that will pop up. So you can add an annotation that way by clicking Note. The first question I already have before I started reading is how can, and then press Save. So I'm going to keep reading. This says Bob Ziak studies plate boundaries. I'm going to pause right here and show you that if you click on that, it will show you what the definition is, both in English and in Spanish, in a surprising way. He listens to them. Ziak is a scientist who works for the National Oceanic and Atmospheric Administration, a government department that studies the ocean and atmosphere. Ziak and his team wanted to know more about what happens on the ocean floor, especially at plate boundaries. Sending people to the bottom of the ocean is difficult, so Ziak and his team used hydrophones, powerful microphones that are built to travel deep underwater. I'm going to pause here, and I actually had already highlighted this, but to show you that, if you just click on that again, highlight will pop up. I highlighted that because I don't know what hydrophones are, but now I see that it tells me in the sentence there that they are powerful microphones built to travel deep underwater. So what I want you to do when you come across words you don't know, when you're actively reading, you're actually thinking about them. Think about what you do know from that sentence. For example, I know what a microphone is. I know that it's something that is built to make people's voices louder. And I also know I've heard hydro before. I've heard hydro in association with water things. Like, for example, a fire hydrant shoots out water. For another example, the hydrosphere is all water on Earth. So if you want to put a note there, you could, or just highlight words that you don't know and see if there's surrounding information in the text that tells you what it is. Like right here, it tells you that there are things that help us hear underwater, essentially. I'm going to put a note there because I'm paraphrasing that. At this point, if you're able to read on your own, go ahead and stop the video and do that. If you would like it to be read to you, I'm going to figure out how to make that happen next. So you can keep playing this if you want it read to you.
Listening to Earth. Bob Ziak studies plate boundaries in a surprising way. He listens to them. Ziak is a scientist who works for the National Oceanic and Atmospheric Administration, NOAA, a government department that studies the ocean and the atmosphere. Ziak and his team wanted to know more about what happens on the ocean floor, especially at plate boundaries. Sending people to the bottom of the ocean is difficult, so Ziak and his team used hydrophones, powerful microphones that are built to travel deep underwater. The team sent hydrophones 10.99 kilometers, or 6.83 miles, down into the deepest place in the ocean, an area known as Challenger Deep. Challenger Deep is an underwater canyon, part of a much larger landform called the Mariana Trench. Ziak and his team didn't expect to hear very much noise so deep below the ocean's surface. What they actually found surprised them. Their hydrophones picked up sounds from many different sources. One type of sound, collected by Ziak and his team, was the sound of plate motion in the form of earthquakes. Earthquakes happen at plate boundaries all over the world. They are caused by the motion of plates. Ziak travels all over the world studying plate boundaries under the ocean and using hydrophones to collect data about the earthquakes that happen there. By recording earthquakes at different plate boundaries, Ziak and his team are using sound to study the ways that plates move on Earth. Listening to convergent boundaries. The Mariana Trench lies on a convergent boundary. In fact, the trench is a convergent boundary, formed by one plate sinking under another. Since plate boundaries tend to have a lot of earthquakes, Ziak and his team weren't surprised to hear some earthquakes on their recordings. However, they heard many more earthquakes than they had expected. Ziak explained that when they recorded sounds from Challenger Deep, there were even more earthquakes than we thought there would be. Our recordings taught us that plate motion is always moving along. At convergent boundaries, two plates are moving toward each other. When the two plates collide or run into each other, one is forced underneath the other. This collision is very slow, but the forces that cause it are very strong and affect both plates. Over long periods of time, the plate that is on top can bend and fold. The plate on the bottom is shoved into the mantle, bending downward and forming a deep trench at the boundary. As the bottom plate sinks into the mantle, it is destroyed and becomes part of the mantle. Both earthquakes and volcanic activity are common at convergent boundaries. Listening to divergent boundaries. Bob Ziak and his team don't just listen to the ocean near convergent boundaries, they also use their hydrophones to listen in on divergent boundaries. Divergent boundaries are the opposite of convergent boundaries. They are places where two plates are moving away from each other. As the plates move, hot material from the mantle comes up to fill the space between them. The hot mantle material cools and hardens and adds new rock to the edges of each plate. Over time, these additions of rock form a mountain range made up of a long chain of volcanoes. When this process happens on the ocean floor, scientists call the landforms a mid-ocean ridge. Mid-ocean ridges can be thousands of kilometers long. By listening to the ocean around divergent boundaries, Ziak and his team can detect earthquakes and volcanic eruptions that humans wouldn't know about in any other way. After all, mid-ocean ridges are deep underneath the ocean's surface and may also be thousands of kilometers from land where people can easily observe them. By lowering a hydrophone into the water near a mid-ocean ridge and letting it record for a long time, Ziak and his team can hear how many earthquakes and volcanic eruptions are taking place. Ziak uses hydrophones to study the smaller earthquakes, called foreshocks, that occur at divergent boundaries before major earthquakes. Big earthquakes at divergent boundaries have a clear pattern of foreshocks, he says. It's not something you see on land, and we're finding this pattern at divergent boundaries all over the world. Ziak believes studying earthquakes in the middle of the ocean may help scientists refine the tools they use to study earthquakes on land. If earthquakes had this kind of predictability on land, it might be something we could use later on, he says. Putting it all together. By studying both convergent and divergent plate boundaries, Ziak is studying the ways that plates move all over our planet. In some places, the motion of Earth's plates works like a conveyor belt. Most plates have a convergent boundary on one side and a divergent boundary on the other. On the side with the convergent boundary, plate material is sinking into the mantle and being destroyed. On the side with the divergent boundary, new plate material is being made at a mid-ocean ridge. The motion takes place at a rate of only centimeters per year, but since one side of the plate is being destroyed and the other keeps getting new plate material, they keep moving. Ziak's research is helping us understand more about how plate motion happens. We just have to listen.